All right, folks, we have a limited time window, so I want to go ahead and get us started pretty much on time here. First of all, thank you all for coming. Please continue to go through the line and get your food and be welcome. My name is Alex Hunt. And first of all, let me just ask you to take a look at your cell phone. Make sure it's silenced, if you would. We're here today to hear from Professor Katharine Hayhoe of Texas Tech University, who's giving a lecture entitled Climate Change in West Texas, Facts, Fictions, and Faith. This took putting this lecture on took the combined efforts of many individuals and departments here at WT and beyond. So I'd like to begin by thanking our sponsors so I don't forget anybody. First of all, the Center for the Study of the American West, or CSAW, was the one who initiated this idea. We have a couple of tables in back if you want more information about what we do. I have to thank the Distinguished Lecture Series here at WT for its funding and support of this event. We reached out also to the WT Philosophy Program. Daniel Bloom, are you here? Thank you, Daniel Bloom, for your support from the Philosophy Program. We also had early support from Dr. Ray Matlack. Where are you, Ray? There in the back. From Wildlife Biology. Thank you for the support from Life, Earth, and Environmental Sciences. We also had huge help from WT's School of Engineering. Emily Hunt, Dr. Hunt, where are you? Thank you, Dr. Hunt. It's kind of like a loaves and fishes thing, but it's pizza, right? Dr. Kathy Cluett, physicist from Department of Chemistry and Physics. Are you here, Dr. Cluett? Thank you for your support from your department. In addition, we collaborated on this event with WT's Baptist Student Ministries. Big thanks to Buddy Young. Where are you, Buddy? He's here somewhere, there in the back. Thank you, sir. Also, Amarillo's South Georgia Baptist Church, who has helped with the refreshments. Thank you very much, as well as other WT campus ministries who've been involved and who are represented here today. Finally, last but not least, we thank the Humanities Texas for their generous support of this event, which is made possible by one of their grants. Humanities Texas is a state affiliate for the National Endowment for the Humanities. So truly broad support from across campus and beyond for this event, which is wonderful. So one procedural note I want to tell you about. At the conclusion of the lecture, there'll be some time for questions. And given the number of people here and the space and the timing, we thought the best way to handle this was with written questions. So if you have your backpacks here, you have your stuff, you can always jot down a question on a piece of paper. We will have people running around collecting slips of paper and bringing them back to Dr. Emily Hunt, School of Engineering, who will be on this microphone in the back when the Q&A session starts. If you don't have a pen or pencil or a slip of paper, there are a couple of baskets back here that have those materials in them, and if you raise your hand, we'll make sure we get you those materials. Okay, so now on to the actual introduction. Katharine Hayhoe is an accomplished atmospheric scientist at Texas Tech University who studies climate change and why it matters to us here and now. Particularly, her research focuses on understanding what climate change means for people and the places where we live. She's also a remarkable communicator. In 2014, she was recognized by Time magazine as one of the top 100 most influential people in the world, and by Foreign Policy as one of the top 100 global thinkers. Her work was featured on the Emmy award-winning documentary series, The Years of Living Dangerously, and she won the American Geophysical Union's Award for Climate Communication. In 2016, she was named to the Politico 50 list of thinkers, doers, and visionaries transforming American politics, while in 2017, she was named one of Fortune's World's Greatest Leaders. She is a lead author for the U.S. National Climate Assessments for the last several years and has served on panels for the National Academy of Science, the American Association for the Advancement of Science, and many other professional organizations devoted to understanding and communicating climate change. Katharine is currently a professor and directs the Climate Change Center at Texas Tech University. She has a BS in physics from the University of Toronto and an MS and PhD in atmospheric science from the University of Illinois. Katharine Hayhoe is an atmospheric scientist who studies climate change, one of the most pressing issues facing humanity today. but she may be best known to many people because of how she's bridging the broad, deep gap between scientists and Christians, work she does in part because she's a Christian herself. As a world-class climate scientist and a Christian, Dr. Hayhoe may defy some stereotypes about the politics of religion and science, but defying stereotypes invites inquiry, which can lead to communication and even learning. It creates opportunity for thinking deeply about and aligning what we value and what we do. Climate change is a huge issue, and it's one where citizen engagement is critical. That's why her work is so fascinating, in part because it's about climate change, and also because her main theme, faith and science, defies stereotypes. So again, our title today, Climate Change in West Texas, Facts, Fictions, and Faith. Please join me in welcoming to WT Dr. Katharine Hayhoe.
Thank you so much for that introduction. I hope everybody got food. If you didn't, there is more food back there, I'm pretty sure. So, living here in West Texas, there's always something to talk about, right? We know that when we live in Texas, we see floods, we see hurricanes. Now, I know we don't see hurricanes here, but we see them, down there where a lot of our friends and family live. We also see crazy droughts, we see water shortages, we have record-breaking wildfires. In fact, did you know that when it comes to really crazy and extreme weather and climate, Texas is #1? Yeah, isn't that crazy? So if you add up all of the climate and weather disasters that have cost at least $1 billion each since 1980, Texas has had 105. You know how many have happened across the whole U.S.? 230. So Texas has almost half of the crazy billion-dollar weather and climate disasters. Why is that? It's because we get everything, right? I mean, what don't we get? So we get tornadoes, really bad thunderstorms and hail. We get dust storms, and dust storms that are so big they have a special name, haboobs, right? We have ice and blizzards. People are always surprised. They're like, oh, you live in Texas, it must be so warm. No, we all know what ice and blizzards look like. Then, of course, we have drought. We have crazy heat waves in the summer. We have incredible heavy rain events and flooding, too. And like I said, we get hurricanes down the Gulf Coast. I mean, we pretty much get everything there is to get, don't we? Now, wherever we live, we're used to the fact that our weather goes up and down from day to day and even from year to year, right? We have hot and cold, and we have wet and dry. And if we live in Texas, it looks like this. Who has not had the experience of walking into a movie theater, a store, your house, a class? It's about 95 out, and you walk out 2 hours later, and it's like 45. Who has not had that experience? I'm not seeing too many hands. Everybody's lived here at least 1 year. In fact, a few years ago, I don't know if you remember, a few years ago, the Weather Channel actually had a competition for the toughest weather city in the United States. And I'm guessing they could only pick one West Texas city. I'm sorry. So Lubbock kind of represents, right? Lubbock went up against Fairbanks, Fargo, and Caribou, Maine, which I had never heard of until then, but by the name you can tell it's pretty tough. And Lubbock won for the toughest weather city in the United States. Now, the crazy thing is, the exact same year that this happened, there was another competition. This was 4 years ago. And this competition was by the National Realtors Association. And Lubbock also won that competition. Which makes absolutely no sense to me, because when you talk to somebody, what is the #1 topic of conversation that you typically have with somebody who you don't know super well, but you just kind of ran into them? It's the weather. So how can Lubbock be the most boring city in the world if it has the most weather to talk about? And not just Lubbock, but all of West Texas. It makes no sense to me. These things are clearly rigged. So if we already have such crazy weather, if you live in a normal place it looks like this, and if you live in Texas it looks like this, then Why do we care about climate? Well, it's because we're used to these ups and downs, but what we don't often realize is that we assume that it all averages out long term. So we assume that this crazy whiplash effect that we have, and let me just show you an example of our whiplash. I don't know if you remember, but in August, 78, almost 80% of this entire state was in drought this August. And then it's been the wettest fall on record across much of Texas. So, I mean, we have whiplash so severe that, you almost can't keep up with it. But weather is what happens in a certain place at a certain time. It's like a single tree. Climate is the long-term average of weather over at least 20 to 30 years. It's like the entire forest of trees. So if our weather is already so crazy, why does climate matter to us? Climate matters to us because a lot of what we do is actually built on climate, not weather. Let me give you some very specific examples. Where do our building codes come from? How big an air conditioner you need? How big of a furnace? It comes from our long-term climate. Some years are hotter, some are colder, but we prepare for the long-term average. How do we know what type of crops we can grow where and when? There's a reason we grow cotton in West Texas. It's because we have the perfect climate. Some years the crop is great, some years the yield is terrible, but on average, this is a good place to grow cotton and corn and milo. How do we draw our flood zones? We look at what happened in the past, where it flooded in the past. How do we plan for the future of our water? We look at how much water we used the last 100 years, and then we account for changes in population, but we assume on average we're going to get the same amount of water in the future. Even our wardrobe is based on climate. Just think about that. Think about the clothes that you have. You would have very different clothes if you lived in Caribou, Maine, right? You would have very different clothes if you lived in the Caribbean, right? Our life, our agriculture, our water, our energy, our infrastructure, our buildings, even the clothes that we wear, it's all built on this assumption that things can go up and down from day to day and even year to year, but long term, it's pretty steady. I bet you never thought about that before, have you? It's kind of like the drive that I did today. So I live in Lubbock, and you know that when you are driving up I-27, there are some parts of I-27 that are so straight that you could stay not just on the highway, you could stay in your own lane if you're simply driving along looking in the rearview mirror. I don't recommend it. So don't go doing it and saying that she told me to do it, no. But you could do that, why? Because the road is so dead straight that where you were 5 seconds ago, 15 seconds ago, 30 seconds ago, sometimes even 5 minutes ago, is a perfect predictor of where you'll be in the future. But just before you get to Plainview, who here, is this familiar to anybody? Yes, okay. Just before you get to Plainview, there's this giant curve in the road. This is going north on I-27, in case you're wondering. And at the curve, there's this row of concrete silos. What happens if you're driving up the road looking in the rearview mirror when you get to the curve? I hope everybody knows. They'll be collecting driver's licenses at the door afterwards if you don't. You're going to run off the road. And so planning for the future based on the past only is like driving down the road looking in the rearview mirror. It works really great when the road is straight, and it works really great when our long-term average climate isn't changing. But what if it is changing? We still get our ups and downs. We still get winter and summer. We still get heat and drought and flood and cold. But long-term, things are changing. And why do we care about that? We care if the long-term average is changing because it affects us. All of a sudden, the infrastructure we have isn't prepared for the conditions it's experiencing. All of a sudden, places are flooding that are not inside the 500-year flood zone. All of a sudden, we're seeing that plants are blooming at a different time of the year. We're seeing, insects and other species moving northward. In terms of how plants feel, in Lubbock, it already feels like Austin did just 25 years ago. So we see that things are changing, and that affects us because a lot of our entire society, our economy, is built on this assumption of a changing climate. It's not just, though, that the average is changing. We're also seeing a change, now don't blink, in the variability. Why does that matter? It matters because we are already number one naturally. Already we're number one, but as we're seeing some of our extremes get stronger or more frequent, who's it hitting first? Us, because we already get all that stuff. So the second reason that we care that our baseline is changing is because it makes the risks we already face today worse. It's kind of like a pair of dice. This is the way I think about it. We always have a chance of rolling a double six, right? And a double six is that crazy drought or that historic flood or the super hot summer. That's a double six. But what we've seen decade by decade by decade here in Texas is we're starting to see that the chances of rolling a double six is going up. So instead of rolling the number we used to, we're starting to see that we're rolling a few more of them. And then we're starting to see a 6 and a 7 show up, and we're like, how could this be showing up? We've never seen something like this before. That's the number one reason why we care about what's happening. But that naturally leads to a question, and the question is this baseline actually changing? Because between the months of November and April, yes, April, because we always get ice storms here. I still remember when so I'm from Canada, and so all of our family thinks, oh, Texas is so warm. So I was having a baby shower in April. My mom was coming down for the baby shower. What do you think my mom packed to come to Texas in April? And what do you think happened? Yeah, there was an ice storm that day. The shorts didn't really cut it. So between the months of November and April, I would say the number one question that I hear is, it's freezing outside. How can you say that climate is changing and it's getting warmer? And that's because, again, we're not talking about weather. We're talking about the long-term change. And so saying that a single day is cold, therefore long-term we can't be getting warmer is kind of like saying, the Titanic can't be sinking because my end just went 200 feet up in the air. So when we look at the long-term data here in Texas, when we look at the weather records here in Texas, and I've done this myself, I've looked at all of our weather stations all across Texas for as far back as we can go, we can see that our baseline is changing. Every single season has been getting warmer since the 1950s. Now, does that mean we don't have cold years? No, of course we have cold years. But long term, every season is warming, and you know which season is warming the most? Winter. So if you've lived here, you know that we used to have quite a bit more severe winters than we do now. And we still have cold, we still have snow, we still have that giant blizzard that hit at New Year's, remember a couple of years ago? But long term, we're starting to see these shifts, and we're also seeing that our summer rainfall is starting to shift away from summer into spring. We're seeing that extreme rainfall is becoming more common, especially in the eastern part of the state. And along the Gulf Coast, we're seeing that sea level is starting to rise. The trends that we're seeing in Texas are consistent with what's happening in the United States and around the world. If you add up all the weather stations in the entire world, and you look at how the average is changing, it goes up and down from year to year, sure. But decade after decade after decade, that baseline is pointing up. Why do we care about it? We care about it because it's taking our naturally occurring risks, it's taking hurricanes, heat waves, droughts, floods, totally natural risks, and it's amplifying them like putting a baseball player on steroids. A lot of these changes we can see in our own backyards. When my colleague, another professor called John Zach, first moved to Tech 30 years ago, he is a biologist. So he had a peach tree in his backyard, and being a biologist, being a scientist, he wrote down the day that peach tree flowered every year for 30 years. And this is in Lubbock, Texas. When he had to cut down the peach tree 2 years ago, on average, it was flowering 3 weeks earlier in the year than it did when he first moved to Lubbock. We have invasive species like fire ants. They're invasive. They were actually brought here. They're not native. But our cold winters in West Texas used to keep them at bay. Not anymore, though. Fire ants are actually spreading up through North Texas because our winters aren't cold enough anymore. So if we look around the entire world, we can throw out our thermometers, we can throw out all our scientific instruments, we don't even need them. If we simply look at plants, at insects, at animals, at changes in things that we can actually see with our eyes, did you know there's over 26,500 independent indicators telling us that that baseline is going up? Isn't that crazy? And some of those we can see right here. So is climate changing? The science says, yes, it is. But then we have to ask, why is climate changing? And probably one of the most frequent questions that I get is, you don't believe in that global warming thing, do you? And my answer to that question is, no, I don't believe in global warming. Why do I not believe in it? I don't believe in it because, according to Google, faith or belief is a strong belief that's based on spiritual apprehension rather than proof. Whereas science is the systematic study of the behavior of the physical world through what? Through observing and through experimenting. So I don't believe that our baseline is tilting up. I actually look at the data and look at what the data tells me. What I love as a Christian is the fact that we don't just have to look at Google. Did you know that this exact definition pretty much is actually in the Bible too? Isn't that crazy? In Hebrews, there's a chapter that talks about faith, and it specifically says faith is what we hope for, so it's not here and now, it's in the future. And it's the evidence of what? Of what we don't see. What's science? If I had been there 2,000 years ago, and if I could jog their elbow, I would have said, hey, you forgot the second half of the verse. Science is the substance of things here and now, the evidence of what we can observe. So I don't believe in global warming because it isn't a matter of belief. Did this horse believe in gravity? I had to get a painting. I didn't want to show a real horse. No animals were harmed in the making of this presentation. It doesn't matter if the horse believed in gravity or not. You step off the cliff, you're going down. So it doesn't matter if we believe that our climate, our long-term baseline here in Texas is changing. If you'll look at the data is very clear that it absolutely is. But then we get to a more contentious question, because most of us here in West Texas, most of us would agree that things are getting different. Most of us would agree that things are not the same as they were, especially if we've lived here for a long time. But most of us also know that there's a lot of natural reasons why climate changes all the time, right? There are. How do we know? Well, if you are one of those people who've watched the Ice Age movies, confession time, who's seen an Ice Age movie? Okay. Now, who's seen them more than once? Yep. Anybody who's a parent of a small child or a grandparent. We know that things have been different before, right? We know that there's natural cycles. We know that there's El Nino, which brings really nice wet conditions to us in the winter and spring like we're going to have this year. But then when we have a La Nina, we have very dry conditions in the summer and hot. And the last big La Nina we had was during 2011 and 2012 when we had record hot conditions and record dry conditions. So when we see climate is changing, we don't just jump on some bandwagon and start screaming global warming. No. What we do is we look at the reasons why climate has changed before, right? Otherwise, it's as if you were running a fever, a long-term fever that sort of went up and down from day to day, but week by week by week, it kind of started to climb up. And you went to the doctor, and the doctor just looks at you and says, Ebola. I mean, that's not a very good doctor, right? Like, there's a lot of reasons why you could have a fever. You could have a fever for food poisoning, an infection, something a bit more serious. So you have to do all the tests. So this is what we have to do. We have to do all the tests to see why the planet is warming. So let me take you through a couple of these tests. First of all, the sun. We know that sometimes we get a bit more energy from the sun and sometimes we get a bit less. During the little ice age that they had over northern Europe back in the 1800s, that was a time when they were getting a bit less energy from the sun. So if our temperature is going up, and this is our year-to-year temperature, that's the thin line, and then the thick line is our long-term trend. If our Earth's temperature is going up because of the sun, what would have to be happening to the sun's energy? It would have to, thank you, it would have to be going down, right? It's kind of like a dimmer switch on a lamp. If you turn the dimmer switch up, you get more light, more heat. Turn it down, you get less. So let's look at the sun's energy. Well, the sun's energy actually has an 11-year cycle that was discovered by Galileo more than 400 years ago. Isn't that crazy? But the long-term average of the sun's energy is actually going down. So according to the sun, we should be getting cooler right now. We're not. So it can't be the sun. What about natural cycles? Well, there's two types of natural cycles. Now, this is really important. You're going to learn something that hardly anybody knows. Isn't it just a natural cycle is one of the most common things people say to me, but then when you say what type of natural cycle, often we don't know. So you're going to know. Ready? There's two types of natural cycles. The first kind happens inside the Earth's system, like El Nino. What does El Nino do? There's dozens of cycles like El Nino that affect different parts of the world. What do? They take heat and they move it back and forth from the atmosphere to the ocean like a seesaw or a teeter-totter. Now, just out of curiosity, how many people call it a seesaw? Okay, how many people call it a teeter-totter? Oh, less. Okay, so we're more seesaw. I'm kind of curious about that because I grew up doing both, and I have to tell you, I don't always ask people, I just ask once in a while. I've only been to one place where the entire room said teeter-totter, and you'll never guess where that was. No, it's not Lubbock. Utah. Apparently teeter-totter is the Mormon word. I thought that was really interesting. I had no idea. Now that's going to be the only thing you remember from this whole hour, right? So what these natural cycles do is they take heat from one reservoir, like the ocean, and they move it to another, like the atmosphere. So when we have an El Nino, for example, El Nino heats up the surface water of the ocean, and it transfers heat from the ocean into the atmosphere. And when we have a La Nina, it cools down the ocean, so then heat transfers from the atmosphere into the ocean. So if our atmosphere were warming because of a natural cycle, that heat has to be coming from somewhere. Otherwise, it would violate conservation of energy. You can't just create heat out of thin air. So if the heat content of the atmosphere is going up, the heat content of the ocean would have to be going down by the same amount for this to be a natural cycle like El Nino. Does that make sense? Okay, I see at least two people nodding. I can see you, so you can nod. So let's actually look at the data. Ready? So here's the data. The green is the change in the heat content of not just the atmosphere, but the land surface and ice all put together. And if it were a natural cycle, the blue would be the same size, but the opposite sign. But it isn't. The blue is the change in the heat content of the ocean. Way more heat is going into the ocean than into the atmosphere. So why aren't we talking about this? I have one reason why we're not talking about this, and that is because we're not dolphins. If we were dolphins, we'd be talking about the blue part. We wouldn't even be thinking about the green part, but we aren't dolphins. We live here on Earth, so we talk a lot about what's happening here on Earth. So it can't be a natural cycle because the whole planet is warming. And in fact, the ocean's warming 20 times more than the atmosphere, land, and ice put together. That's why we know it's not El Nino or a natural cycle. Now, there's a second type of natural cycle that is actually due to changes in the Earth's orbit around the sun. Changes in the Earth's orbit happen over very long periods of time, and they actually change the way that sunlight falls on the Earth. The fascinating thing is this was discovered by a guy, a Serbian man called Milankovic, during World War I. He was just finishing his PhD in concrete engineering. I'm sorry, that sounds super boring to me, but back then, 100 years ago, apparently it was cutting edge. So he was just finishing his PhD in concrete engineering at the university in Hungary when World War I broke out. And unfortunately, he was from the wrong side of the line. He was a Serb. So he was about to be sent to an internment camp. But one of his professors, who was Hungarian, so he was on the right side of the line, he spoke up and he said, can you put him under house arrest at the university where, I'll keep an eye on him and he'll just come to the university and work and we'll make sure that he doesn't, get involved in the war. So they said, okay, he can do that under one condition, and that is that he doesn't work on anything to do with the war. And if you know anything about history, World War I was all about trench warfare. What were the trenches made out of? Mud if you weren't lucky, and concrete if you were. So he couldn't work on concrete engineering. So he looked around and thought, what should I work on? Why don't I figure out why we have ice ages? And he did. Isn't that interesting? So rather than figuring out how to do concrete better, I think we've figured that out pretty much by now, he worked on figuring out why we have ice ages, and he found out that it's due to these changes in the Earth's orbit around the sun that are totally predictable. It's just simple mathematics. So then people say, well, so aren't we just getting warmer after the last ice age? Well, first of all, according to those orbital cycles, you can calculate exactly where we are. And you know where we are in those orbital cycles? We should be heading into another ice age sometime in the next 1,500 years. That's not good news, because last time we had a big ice age, the continent was covered in a mile of ice. Canada did not exist, except for the Yukon. There were actually parts of the Yukon that were not covered in ice, surprisingly. But then the second thing we know is if we actually look at the data, if we look at the thermometer records that go back to the 1600s, and then if we look at the natural thermometer records in tree rings, did you know that trees have a ring every year, right? And the width and the density of the ring tells you about the temperature of that year. You can put together those records. You can put together historical records of when the cherry trees bloomed and when the river froze. You can put together ice core records of little air bubbles in ice cores that trap not just the levels of gases in the atmosphere, but they actually tell you about the temperature of the atmosphere when the bubble was formed. You can do that, and what we see is that our temperature was what? It was going down. If you look at the history of human civilization on our planet, you look at the last few thousand years, our planet was slowly, gradually cooling to head into the next ice age until something happened. Isn't this a crazy figure? I mean, this really shows that what is happening today is not like we've seen before. In fact, let me just jump ahead. People often say, I don't know if you've heard this, but I get this a lot. I get a lot of people asking me questions, and people say, what about the medieval warm period? Wasn't it warmer during the medieval warm period? Now, you might be looking at this figure going, where's the medieval warm period? I will tell you where it is by showing you a map. This is a map of the medieval warm period. Where was it warm during the medieval warm period? Over the North Atlantic. Not nowhere, but over the North Atlantic. And where does a lot of our cultural tradition come from? It comes from Western Europe, right? So the medieval warm period is very implanted in people's heads, in the idea that there's this super warm time when the Vikings moved to Greenland, when they grew grapes in England. They're growing grapes in England right now, too, by the way. We have this idea that there was this giant medieval warm period. Well, this is a perfect example of a natural cycle, because what do natural cycles do, like a teeter-totter or a seesaw? They move heat around the Earth. So what happened was these natural cycles moved heat over to Western Europe and the North Atlantic, and where did they take that heat from? Yeah, Russia, Siberia, Eastern Europe. That was colder than average. If you talk to a Russian and you say medieval warm period, the Russian would be like, what are you talking about? That was a mini ice age. And then let's compare this on the exact same scale, the same scale. Let's compare this to the last 20 years. Ready? It's a bit different, isn't it? Yeah. So yes, we absolutely have seen warm periods and cold periods in the past, for sure, of course we have. The only reason we know about it is because climate scientists like me actually study it. It always kind of kills me when somebody's like, oh, you've never heard of natural cycles. I'm like, who do you think studies natural cycles? It's like telling a doctor they've never heard of germs. We actually study natural cycles, and that's why we know that what we're seeing today is so unusual. So here's the situation. All of our natural suspects have an alibi. It can't be the sun, because we should be getting cooler and we're not, we're getting warmer. It can't be natural cycles like El Nino, because it's not just the air, it's the whole planet, the ocean, the land surface, everything's getting warmer. And it can't be the orbital cycles, because the next thing coming was another ice age. So this is finally, kind of like a physician or maybe like a CSI detective, this is finally when we turn from all the natural causes and we could say, what could it be? And when we look to see what it could be, there's a giant clue right here. You see it? It's kind of hard to miss, isn't it? What happened just a few hundred years ago? What happened was we figured out how to dig up massive amounts of coal and gas and oil and burn them to power our civilization. Now, let me just stop here for a second. The Industrial Revolution was an incredibly good thing. Why? The Industrial Revolution replaced human labor, and it actually disproportionately replaced women's labor. Do you know how long it took to wash clothes? By hand? Do you know how hard it is to prepare food from scratch every single day? No refrigerators? You know what else coal and gas and oil replaced? Slavery. That is the reason why the United Kingdom was able to outlaw slavery in the early 1800s, and that was why the North was able to continue to industrialize and prosper without slavery, and the South could not. So the Industrial Revolution brought us tremendous benefits. If it were not for the Industrial Revolution, we wouldn't be sitting here today, right? We wouldn't have lights. We wouldn't have cars. We definitely wouldn't have computers. I don't think we would have had many of the medical advances we've had in the last 300 years, and if we didn't, I'd probably be dead. So the Industrial Revolution is a really good thing. But as we also know, there's no free lunch. And the Industrial Revolution had a side effect that we didn't know about 300 years ago, but we do know about now. So while we can be grateful for the benefits it brought us, we also have to be aware that today we're starting to see a shift. And we're starting to see that shift because burning coal and gas and oil produces something called carbon dioxide. Now don't worry, this is the only chemistry that you're going to get. Don't worry. Why does that matter? Here's why. It's because our planet already has a natural blanket of heat-trapping gases. Here's our happy planet with its natural blanket. The sun's energy shines down and goes right through this blanket like a window, and then the Earth absorbs the sun's energy and heats up and gives off heat energy. And this blanket, just like a blanket keeps us warm on a cold night, this blanket traps the Earth's heat energy, keeping our planet more than 60 degrees Fahrenheit warmer than it would be otherwise. If it weren't for this natural blanket, we'd be a frozen ball of ice and there'd be no life on the planet. Well, so if it's entirely natural, what's the problem? The problem is that by digging up and burning coal and gas and oil, we're wrapping an extra blanket around the planet that it did not need. And just like when I used to go stay at my grandma's house and she would sneak in every single night and put an extra blanket on me, and I would wake up sweating, saying, "Grandma, I don't need this extra blanket." In the same way, we're wrapping an extra blanket around our planet, and that is why it's running a fever. Now, you thought this was complicated, but you know what? You can explain it in 60 seconds with a cartoon. So why is climate changing? It's got to be the fact that we're wrapping an extra blanket around the planet. There's no other reason. But then we have to say, okay, but so what, right? What does this mean for us in West Texas? Because if you see a movie or a book or a poster about a changing climate, what's the number one image that you're going to see on that book or that poster? The number one image is a picture of a, you guys are too knowledgeable here, the front row. I'll give you a clue. Yes, it is, there's ice involved, and the thing is very big. It is furry. Yes, thank you, exactly. It is a polar bear. That is the number one thing you're going to see. Okay, so I'm Canadian, and we do have polar bears running around in the streets. Just kidding. We don't. In fact, I was just up in Canada, and I was meeting with a group of colleagues, about 100 of us, and I asked a room full of 100 Canadians who study this, how many of you have seen a polar bear in the wild with your own eyes? You know how many people put up their hand? 4, and I was one of them. So if the number one symbol of this problem is some animal we've never seen, and honestly, if we do see, we hope we don't, because they're the biggest carnivore on the planet. They can run faster than you can imagine. They will eat you for fun. If that's the symbol of a changing climate, who cares? That has nothing to do with us here in West Texas. So what does this changing baseline mean for us in West Texas? Again, we care about it because it affects that baseline that we have built our society, our economy, our agriculture, our water, our energy on, and our wardrobe. Minor consideration, but still. And we also care about it because it exacerbates the risks that we face today. Like what? Well, over the past 50 years, we've seen that our heavy rainfall is getting more frequent because the warmer the air, the more water it can hold. So there's more water vapor sitting there, so when a storm comes along naturally, as it always does, it can sweep up all that water vapor and it can dump it on us. That's one way that we're being affected. Another way we're being affected is that we're seeing a risk of more summers in the future, like 2011, when we had dozens of days over 100 degrees across most of Texas. Nobody wants that summer to come back, but there is a risk that it could come back because that baseline is changing. And then, of course, we know that hurricanes get their energy from where? Hurricanes get their energy from the ocean. The extra blanket that we're wrapping around our planet is trapping a lot of heat. And remember, we learned this about the teeter-totter and the seesaw. Where's most of the heat going? Into the ocean. What is it doing in the ocean? I'll tell you one thing it's doing. It's powering stronger storms. So we aren't seeing more frequent hurricanes. I know last year was bad, but long term, again, climate is the average of weather over 20 to 30 years. Long term, we're not seeing more hurricanes, but we are seeing stronger hurricanes with more rainfall associated with them. In fact, it's estimated that if Hurricane Harvey had happened 100 years ago, as it very well could have, because hurricanes are natural and they happen all the time. Galveston had a really bad hurricane back in 1900. If Hurricane Harvey had happened 100 years ago, it would have had about 40% less rain associated with it. Isn't that crazy? So it's taking naturally occurring events like that dice and it's amplifying them or exacerbating them. The reason why we care about a changing climate is because it's loading the dice against us. And here's the thing, though, it isn't just loading the dice against us here in Texas. Heat waves in India, typhoons in the South Pacific as well as in the Gulf of Mexico, heavy rain events in Southeast Asia, wildfires across the entire Western U.S. We're seeing these changes all around the world, and one of the biggest reasons why I personally care about this is not because of my science, it's because of my faith. I don't just believe, like it says in Genesis, that we're called to be responsible for or to have dominion over every living thing on this planet. I also believe that we are to care for those who are less fortunate than us. And the reason why we care about a changing climate is because, yes, it affects us right here, absolutely, but it also takes issues like hunger and poverty and disease, and it exacerbates them or it makes them worse. The reason I care about a changing climate is because the people who are most vulnerable, their crop yields, their water supply, their health, their resources, those are the people who already don't have enough. That's the reason why I care. So, last question, and really probably the most important question, right? What are we supposed to do about this? Here you are coming along talking about this big problem that's affecting us. What are we supposed to do? Well, one of the most important things we can do, first of all, is recognize that no matter where we live, here in Texas or on the other side of the world, there's a curve in the road. Remember driving up to Plainview, curve in the road? There is a curve in the road, so it isn't enough anymore to just look at the past. We have to recognize the world is changing. We have to prepare for hotter and drier conditions so that when they come along, we're not surprised. What's going to help us do that? I'm going to tell you one thing, the most important thing you can do. Ready? It has nothing to do with light bulbs. You'll be happy to know. Or maybe not. Maybe you want me to talk about light bulbs. The one most important thing every single person in this room can do is talk about it. Did you know that only 1 in 5 people hear somebody else talk about this issue at least once a month? Nobody talks about it. And if we don't talk about it, why would we care about it, right? And you might say, okay, but I'm not a scientist. I can't get up and talk about all the sciencey stuff. Don't have to. Don't have to talk about sciencey stuff at all. What's the most important stuff to talk about? The most important stuff to talk about is what we're already doing about this, because you know what? We're already doing a lot. Did you know here in Texas, We already get almost 20% of our electricity from wind. We have 25,000 jobs in the state because of that. Now, we need energy, right? Poor countries need energy too, but we're getting energy in a way that doesn't produce heat-trapping gases that are wrapping an extra blanket around the planet. Fort Hood, biggest military base in the US, which of course is in Texas, they went with wind and solar energy 2 years ago because they calculated they could save taxpayers $165 million because wind and solar in Central Texas is cheaper than natural gas. Every spring we break a new wind record because they put up more and more turbines and then the wind blows harder and harder. And then we have entire towns like Georgetown that have decided to go 100% clean energy. Why? Because 3 business students from the local college looked at the numbers. That's a pretty cool thing that you can talk about because although people like to argue over the number that a thermometer gives us, everybody likes saving money, right? And there's nothing wrong with that. Why not save money? Doesn't matter why we're doing it. All that matters is what we do. I love talking about what churches are doing. This is a church in Minnesota that decided to not just put solar panels on their roof, but offer it to the community as a solar garden, so to speak, so people could buy in, because it's a lot cheaper to put one giant set of solar panels on one giant roof than to put little ones on little roofs. And then I was in the UK last year, and Gloucester Cathedral, which is over 1,000 years old, they actually filled out all the paperwork that they needed to put some solar panels on their roof too, and they were very proud of them. In England, which has not nearly as much sun as we have. I love talking about what companies are doing. The richest company in the entire world is Walmart. Number 1, you can look it up. And they plan to generate half their energy from renewable sources by 2025, and Apple, which is number 11, is already 100%. Facebook has a big data center in Fort Worth that's powered by Texas wind. Around the world, Morocco has the biggest solar farm in the entire world. The UK has the biggest offshore wind farm in the entire world. And if you had to pick one country in the whole world that has more wind and solar energy, is shutting down coal plants faster than any other country in the world and selling that coal to other countries. If you had to pick one country, who would that country be? Close, but no. Isn't that crazy? That's not what you expected. China is changing fast. And what encourages me personally, because I grew up as a missionary kid in South America, so again, I know what poverty looks like, and I know that people need energy to grow. And I know that there's nearly 1 billion people in the world who don't have energy, and many of those live in sub-Saharan Africa. What I'm really encouraged by is the fact that the fastest growing type of new energy around the world is pay-as-you-go solar in Africa for poor people who don't have access to it. So I love that we can also work to end energy poverty in ways that will last. Because what's the bottom line here? The bottom line is, and here's a blue sky this time, we're all in a giant bus driving down the road, and we want to make it sure that we get around that curve to ensure a safe future for us all. So what's the most important thing you can do? The most important thing you can do is, thank you, talk about it. Because the bottom line is, it isn't all about the data and the facts. It's the fact, in the words of one of my favorite scientists, Jane Goodall, it's only when our clever brain and our human heart can work together in harmony that we can achieve our full potential. Thank you. Now, I know some people have class, so before you stand up, let me tell you one thing. I do a PBS series called Global Weirding on YouTube, and every other week we produce a new episode that's about 5 minutes long, and it answers a lot of the questions I talked about here. But the week in between, I have a live Facebook chat. So if you have questions but you have to leave, you can tune in tonight. It's actually tonight at 8 o'clock on Facebook. You just go to my Facebook, which is my name, Katharine Hayhoe. You can find it through my website if you're looking. Go to Facebook at 8 o'clock, and we usually have a couple hundred people, and we get through about, 50 or 60 questions. So you can tune into my Facebook page tonight at 8 o'clock if you want to. Check out our Global Weirding videos. Every single one is super short, and it starts with a question that I'm asked all the time. But if you have class, now's a good time to rise up and leave, and then we will take questions afterwards. Let's just give everybody a minute.
Testing. Yeah.
Yes, thank you. There we go. This is the YouTube website if you're looking, just so you know what it looks like. It's called Global Weirding. And we have super short episodes here on questions, including, what about the ozone hole? What's the difference between climate and weather? Don't developing countries need fossil fuels to reach the same level of development that we have? And my favorite one, actually, our most viewed episode, I did not know what would be the most viewed episode. Turns out our most viewed episode is, the Bible doesn't talk about climate change, right? Everybody wants to watch that episode. It's so interesting. So this is where you can find me online, and then if you're interested in joining our live chat, you can join our live chat on Facebook, and here's what it will look like on Facebook, just so that you know that you're in the right place. Just give it a minute here, and it will show you the page. All right, Alex, do we have questions? You got questions back there?
Okay. Do you think that one reason people struggle to acknowledge the reality of climate change is because of the guilt they feel for what they or their ancestors have done with fossil fuels? Is our struggle with guilt part of the problem?
Absolutely. I'm so glad you asked that question. I think it is, because none of us want to be the bad guy. I don't want to be the bad guy. And when we feel like everything we do, so I was actually once at a meeting with a bunch of faith leaders, and there was a guy there I remember from a Catholic community, and he looked at everybody there and he said, every time you're turning on your car, you're sinning. And you know what I felt like doing? I felt like getting in a Hummer and just driving circles around him. Because I felt like, well, thank you. So when I go to my job to make money to support my family, as well as to support many of the good causes that I support, like, World Vision and things like that, so you're saying that that's a sin. When my child is sick and I need to take him to the doctor, you're saying that's a sin. When I'm driving to church, you're saying that's a sin. It made me so angry that he was just using that guilt to try to manipulate us, that it was absolutely counterproductive. And so that's why I wanted to be very clear that the Industrial Revolution brought us a lot of benefits, didn't it? We need to be grateful for the benefits that it brought us. We need to be conscious of the fact that many countries were not so fortunate. If you look at the richest countries in the world, they're the ones that had the most coal, oil, and gas. The poor countries of the world are the ones who didn't have those resources. But at the same time, we can acknowledge that there's a different way to do things today, that the world is changing and that we need to change because there were unintended side effects of what brought us the benefits that we have today. So we can be absolutely grateful for the past, but at the same time acknowledge that it's time to move forward into the future. People around the turn of the century in the 1900s, they often talked about oil as a gift from God. In fact, there's a whole theology built up around oil being a gift from God, even a gift to the North during the Civil War. There's even articles about that. Yes, I do think fossil fuels are a gift from God. They've helped us a lot. But you know what else is a gift from God? Wind, sun, rain, tide, geothermal energy, even nuclear. The brains that we have is a gift from God. My favorite verse is from Timothy, where it says, God has not given us a spirit of fear, but a spirit of power, love, and a sound mind to make good decisions. So we have been blessed with a tremendous number of gifts from God, and God, as we know in the Bible, talks about us being good stewards of those gifts, of using those gifts. And I feel like we've used fossil fuels pretty much to their full potential, and now it's time to consider what other gifts we've been given. So, thank you. That was a great question.
Is the ozone layer healing itself?
Ooh. So we actually talk about that. This is why I love having my computer up, because you can actually see stuff. We talk about that in our second most recent Global Weirding episode. So if you go to Global Weirding and you look for this one right here, it talks about the ozone hole. The ozone hole happened because we started to manufacture all these chemicals that were really good at air conditioning and really good at refrigeration, but we didn't realize they were also really good at destroying ozone. They were invented by an engineer at General Motors back in the 1920s, because before these chemicals were invented, we were using some things that were very flammable and explosive, to the point where going to the fridge was like Russian roulette sometimes. Yeah, imagine that. So it took about 50 years until scientists down in Antarctica were measuring ozone, and they found a really serious drop in ozone levels way up there, a protective blanket around the Earth, and they thought, there's something wrong with my instrument. That's what they literally thought. But then they talked to somebody else, and somebody else said, I found this really weird thing. And they're like, I did too. Pretty soon they all realized that they were all finding these tremendous drops in ozone levels, which, why do we care about them? We care about them because they protect us from ultraviolet radiation from the sun, which of course is responsible for skin cancer. So they found this huge drop. They told everybody about it. All the governments in the world got together, and in 10 years, they had an international agreement to reduce and eventually eliminate these gases. It was a huge success. And so it takes a little while, it takes a few decades, but they are measuring recovery now. The last few years, they've actually been measuring the recovery, and it's a tremendous triumph for people coming together, recognizing that, oops, we invented something that was really good and actually did save lives, but it had an unintended side effect, so now you know what we're going to do? We're going to use the brains God gave us to invent different chemicals that are much safer but do the same job. And that's what we did. So we've done it once, we just need to do it again. Thank you.
How has 2 years of the Trump administration affected the practice of climate science?
Ooh, that's a tough question. So there's no denying that a lot of people think a thermometer gives you a different number depending on if you're Democrat or Republican. But it doesn't. I'll tell you what is different are the solutions. And so that's why when I talk about the science and when I talk about the solutions, I want to be very clear with people that, first of all, I am not a Democrat or a Republican. I'm Canadian. My husband is a Republican, though, and all my in-laws are. But the solutions come from a broad range. Often people think that the only solutions come from one part of the political spectrum because that's all we hear about. Did you know that there's a libertarian organization called the Niskanen Institute that has libertarian solutions to climate change? Did you know that there's a free market institute called the Energy Enterprise Institute, led by Bob Inglis, who's a two-time Republican congressman from South Carolina, that has free market solutions? Did you know that there's a bipartisan climate solutions caucus in Congress today that has 90 members because you're only allowed to join when you join with somebody from the other party? So you have to join in pairs. And they're talking about proposing bipartisan legislation within the next year or two. Yes. These are the solutions we need to be talking about because by making the science, by making what a thermometer tells us a political issue, first of all, it's like stepping off the cliff and saying gravity isn't real. Leonardo da Vinci said that the most dangerous mistake people make is assuming their opinions are reality. That was Leonardo da Vinci. So apparently humans don't change ever. But by acting as if the science is somehow liberal or conservative, what we're doing is we're not hearing from the conservative voices that have solutions. And we need those solutions because there's some really amazing solutions that we are not hearing about. For example, let me just give you one. Did you know that having all those heat-trapping gases and extra carbon in the atmosphere, that's what's wrapping our blanket around our planet, and it's bad. But did you know that putting that carbon into the soil is good? Yeah, if you're a farmer, you did know that. But we have been systematically depleting our soil of its resources, and if we can put carbon back in the soil, it says, as one expert told me, it's like Miracle-Gro on steroids. It's a natural way of fertilizing average or marginal soils. It's very low cost because how do you get the carbon back in? One way is to burn agricultural waste at a very high temperature. It's called pyrolyzing it. Then you get this powdery black stuff called biochar. You plow it back into the ground like native people have been doing in the Amazon for hundreds of years, and it fertilizes the ground and it keeps the carbon out of the atmosphere. People are not talking about this stuff. And we need to be talking about these solutions because it makes sense. At Texas Tech, they're investigating how sustainable grazing practices can actually sequester carbon in the soil. In Nova Scotia, where I just was, one farmer, to save money, started to feed his cows the seaweed that washed up on the shore. Well, one of the biggest ways that we as individuals produce heat-trapping gases is with our diet, because eating cows and to a lesser extent pigs and lamb, these ruminants, they're called, right? They produce a lot of methane, and methane's a very powerful heat-trapping gas. You may think some of your relatives produce a lot of methane too, but no, cows produce a lot more. So one of the most important things we can do individually to reduce our personal impact is eat lower down the food chain on a consistent basis. But this farmer in Nova Scotia discovered, by accident, that if you feed your cows seaweed, it eliminates all their methane emissions. I mean, that's incredible. So now at the University of California, Davis, they're trying to figure out how to grow massive amounts of the seaweed because there isn't enough in eastern Nova Scotia to pick off the rocks and feed to all the cows in North America. But if they did that, they would eliminate heat-trapping gases from cows. And you know that's actually good because methane is a sign of incomplete digestion. So it's basically like feeding the cows probiotics, helping them digest better, so they turn more of their food into meat or into dairy, win-win, and they reduce their heat-trapping gas emissions. We need to be talking about these solutions, and we're not because we don't have, this issue is so divided that you can't even bring it up in polite conversation, right? I mean, you mention the words, and it's just like immediately the argument begins. And unfortunately, rather than arguing over what we disagree, I really think we can have positive, constructive conversations over really helpful solutions that are good for us and that benefit everybody, and we could see tremendous forward progress if we could talk about that. So when you go out and talk about it, that's the best thing to talk about is the solutions. All right, thank you.
Okay, is global warming affected by not recycling plastic?
Oh, so recycling is a good thing to do because it's taking stuff that we've used and it's keeping it and turning it into something else. And that helps to conserve the resources that we have on this earth because we don't have enough resources to go around. You know, the whole waste not, want not, the whole, reusing things, it's just a good thing to do. It's what our grandparents did. It doesn't directly affect this extra blanket we're wrapping around the planet, except that they've discovered that when plastics decay and break down, they do produce a little bit of heat-trapping gases. So a tiny, 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 weensy little bit is produced from decaying plastics. But the bigger problem we have is plastic pollution. Have you guys heard about that? There's a giant plastic patch in the middle of the Pacific Ocean that's, comparable to the size of Texas almost, which is crazy. And then there's microplastics in almost everything that we eat and drink these days too. And scientists don't even know what impact that has on our bodies. So there's a lot of issues with the fact that we haven't thought about the way we did things. And plastics bring us tremendous benefits, but there might be side effects that we didn't know about. Fossil fuels bring us tremendous benefits, but there might be side effects we didn't know about. Can I see the pattern here? Yeah. So God has given us tremendous gifts, but God has also given us the brain we need to carefully consider what we're doing to make smart decisions such that we're all okay. Thank you.
Okay, last question. If you were dictator for a day,
yes, that is my dream. Do tell.
what policies would you implement?
Ooh, that's tough. As a scientist, I like to say I'm policy agnostic in that I'm okay with anything that works that people are happy with. That's what I would like to see. Now, that is obviously a pipe dream. Nobody's ever going to be happy with everything, right? But as a human, I have to say that one of the solutions that I have seen people like the most is putting a price on carbon. Now you might say, why would people like that? Here's why. We're already paying the price. We're already paying the price because FEMA is paying out more and more and more money to cope with these natural disasters that are being amplified or exacerbated by a changing climate. We are already supporting the fact that fossil fuels are subsidized to the tune of $160,000 per second. Wind and solar is subsidized about 1/5 of that. So one of the free market solutions actually is to take off all the subsidies and then just let the chips fall where they may. But in the province of British Columbia in Canada, they put a price on carbon such that people could understand if I buy X versus Y, X produces more carbon and Y produces less. So more people would buy Y because it produces less and less people would buy X. But here's the key. What did they do with that money? Because nobody wants to hand another giant pile of money to the government. What they did was they set it up such that every dime that they collected went back to people in their taxes. So they lowered personal income tax rates and they lowered corporate income tax rates to one of the lowest in Canada, or one of the lowest in North America actually. So every household actually benefited. The poorer households benefited most with a couple of extra $1,000 each year. And then the better off households benefited less. And then they polled people 10 years later. When I say they, it's people I work with. So it wasn't British Columbia, it was people I work with who do research, polled everybody in British Columbia, and they said, are you in favor of putting a price on carbon? And the entire province said yes. And they polled the rest of Canada, and the rest of Canada said no, but they had never had one. So personally, I just want something that works. I want something that people are happy with. And so based on what I've seen around the world, that's one example of something that people are happy with. I mean, who here would not like their taxes to go down by $2,000 to $3,000? Okay, no hands went up. If a hand went up, I was going to ask them to come see me because you could just, we would all like that. So let's try to think of constructive, positive solutions that people can agree with on each side of the aisle. But here's the thing, to even start talking about this, we have to start talking to each other. So what I want you to do is I want to challenge you. I know. I want to challenge you over this coming week to have one conversation with somebody. One conversation. Not about the science, but you could say, hey, I went to this talk and you wouldn't believe what she said. She said that, insert a really cool solution. She said that they have power plants now that are sucking carbon dioxide out of the atmosphere, turning it into fuel. It's expensive, but it's getting cheaper. She said that you can feed cows seaweed and it totally cuts their heat-trapping gas emissions. She said that at Teck, they're investigating sustainable grazing practices that put carbon back in our soil and make them richer and better able to grow. She said that here in Texas, we have 25,000 jobs in the wind energy industry. Isn't that cool? Since 2014, so 4 years now, the fastest growing job in the whole US, according to the US Bureau of Labor, has been wind energy technician. In Wyoming, a Chinese company went into Wyoming and offered free retraining for coal miners to learn how to do wind energy installations. In San Antonio, you know how the oil and gas industry is here in Texas. I mean, boom, bust, boom, bust. Last time it went down, a ton of people lost their jobs over, in Midland area, south of Lubbock. And a company in San Antonio was just starting up a solar panel manufacturing factory because they couldn't keep up with demand because so many people wanted them in Central Texas, not for their homes, for big farms. And we have 2 big farms going in just outside of Lubbock, too. So they took in a bunch of people who had just lost their jobs in the oil patch out in the Permian Basin, and they offered them free retraining for permanent long-term jobs that don't involve a boom-bust cycle. So there's stuff like this going on, and these are the conversations that we need to be having, is how can we help the people who have been working their whole lives in an industry where they support their families, but they're really worried about what's happening. I mean, the coal industry has been declining for 30 years. There's no war on coal. It's just the fact that it's a very dirty, inefficient way of getting our energy. Coal is about 26 to 28% efficient. Natural gas is over 60% efficient. So it just isn't even efficient to use coal. So the coal industry has been suffering, but rather than trying to offer them false hope, rather than trying to invest in horses and buggies when Henry Ford is already producing the Model T Ford, how about stepping into coal mining communities and saying, you need help and you need jobs, and we're actually going to invest in getting you real jobs that will last you long term. These are the conversations that we need to have. So pick out one thing I talked about that you thought was cool or interesting, not the teeter-totters and the seesaws, anything but that. And my challenge to you is have one conversation this week. Thank you. Now this will be videoed, right? It has been videoed, so you'll be able to find it online too if you want to share it. And don't forget to check out our global weirding videos.
Have you published these ideas?
Which ones? The stories of hope. I actually put them mostly on my Facebook page. And the hopeful stories are the ones that get the most likes. But that's a great idea, just making like a giant list of all the hopeful things. That would be a fantastic idea. Thank you.
Thank you, Katherine.
All
And
right.
we do intend to post this lecture on the CSAW website. And if you Google West Texas A&M CSAW, C-S-A-W, you'll find us. Thank you. Thank you, everybody, for coming.